Welcome back, Physical Science 20. This is 6.5 booklet, Mass and Number of Entities. So if we take a look here, we're dealing with very small things here when we talk about atoms. So we need to have a way of identifying what we're dealing with. And of course, depending upon the bonding of the atoms together, kind of determines what is that substance we're in fact talking about. So first of all, if we were to simplify things a little bit, determining the number of entities, in real life we of course have names for things. For example, dozens of donuts, etc. So that is our entity there. 60 donuts, for example. If we have 5 dozen, 5 times 12 donuts for every dozen, 60 donuts. When we're dealing with water, H2O, that is a molecule. So the entity there is a molecule. So 6.02 times 10 to the 23rd molecules per 1 mole if we're dealing with moles. Okay? So, and I think we mentioned this earlier on, that we're dealing with, if we have single elements, we're talking about atoms. If we're dealing with non-metal substances bonded together, those are molecules. If we're dealing with metals and non-metals, those are formula units. So over here, the representative particles or entities that we're referring to are atoms, molecules, or formula units, depending upon what the substance is. Okay? So, and if you look back at your earlier booklets, you'll see that if you forget what atoms are, molecules, and formula units. Okay, so we take a look here. A pure substance consists of atoms, molecules, or ions. And of course, ions is something else too. We'll get to that too when we're looking at the formula. To find that, we need to first know how much of we have. So if we look at this example, calculate the number of atoms in a sample of gold, and we have 1 kilogram of it. Now, of course, a kilogram is 1,000 grams. So here we're talking about 1,000 grams. So to go to atoms, or representative particles, and we're starting off with grams, there's 2 steps we have to do. We have to change to moles first of all, and then use the factor of 6.02 times 10 to the 23rd to figure out how many atoms we're dealing with. So it's a 2-step conversion. So I usually joke and say we're doing some 2-step and put on your cowboy boots. So here we have grams to moles to atoms, and they have it worked out here. In this example, they kind of break it down to 2 steps. What I like to do though is just combine the 2 steps into one big step. So we're starting up with grams. The first process will go to moles, and then the next step will go, once you have it in moles, go from moles to the representative particle of atom. Moles to the representative particle of atoms. So if we look here, and of course, to do that first step, to go from grams to mole, we're going to have to figure out the molar mass. We're dealing with gold here, so all I have to do is look up the periodic table. And 1 mole over the grams. 1 mole is 196.97 grams of gold. So if we look that up in the table, 1 mole of gold atoms is that. Okay, so grams cancel, we're left with moles. So in the second step, we'd multiply by this. 1 mole is 6.02 times 10 to the 23rd particles, or in this case atoms. So moles cancel, and we're left with atoms. So you can see, cancel, 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 and then the unit we need is left up on top. Okay, so in your calculator, 1,000 times 1 times 6.02 times 10 to the 23rd divided by 196.97, and I suppose divided by 1, but of course that doesn't make a difference. We would get 3.05630 times 10 to the 24 atoms of gold, but if you look here in the original question, 1.00 is 3 sig figs, so 1, 2, 3 sig figs, 3.05, this is a 6, so this gets bumped up to 6, 3.06 times 10 to the 24 atoms of gold. Okay? So a 2-step conversion there. We can make it in one big step. Okay? So combining steps, yeah, and the second example here talks about combining steps. So I kind of got ahead of myself, and here they have it listed there. So changing to moles, and then changing to atoms. So they run through it there. And there's a second example here as well you could run through and get that. But I want to jump to the practice questions here. Maybe do one with you here. Then if you want, you can do the other 3 here, because it's nice they have the final answers. Typical car battery contains 8.16 kilograms of lead. Determine the number of lead atoms in the battery. So of course, 8.16 kilograms, 1 kilogram is 1,000 grams, so 8,160 grams. Okay, so we're going from, so we have it in grams, going to atoms now. So I just kind of snuck this up top here. So of course you look on the periodic table, 1 mole of lead is 207.2 grams. So grams to moles again, 1 mole over the mass of a mole. So there we go. And of course what you could do is grams of lead cancels with grams of lead. I'm left with moles at this point. Next step, moles to atoms. There we have the factor. There we have the factor. And of course you know if you're doing it right if you can cancel off the unit you were at with the unit on the bottom here. So we get 2.37 times 10 to the 25 atoms of lead, 3 sig figs, because the original number had 3 sig figs. So if you like, you can stop the video there and just try number 2, 3, and 4. But I think what I'll do is I'll end the video off there because there's a few other things here I'd like to look at, and to save time we'll maybe do that. So I'll stop the video now. You try number 2, 3, and 4, or at least try one of them just to see if you can do that. Okay, we'll see you again.